Greetings to everybody and welcome to Acadec's Higher Engineering Academy, building your engineering career. For the sake of self-presentation, I am Sir Godwill Yakum, a people engineer at the National Advanced School of Engineering of Yaoundé. Today in this video, we are going to be answering a particular past concours question. We are going to be answering the past FET question of 2018 session Mathematics Part 1. We are going to answer just Part 1. It entails a section of the paper. Now, but before we get started with the video, I would like to present to you some important information that you need to know while preparing for this exam. To start with, for the exam session of 2023, the exam is scheduled for the 13th of September 2023, and displayed on your screen right now, as you can see, you have the various engineering training programs that you can register for and the number of spaces that are available for each engineering training programs, giving a total of 325. We have electrical and electronic engineering, computer engineering and software engineering. We have civil engineering, mechanical engineering, and the total that gives us 325 places. Now, how is the paper structured? The structure of the question paper is the same for all the fields, all the different engineering training programs. They have the same structure of the paper. We have the mathematics paper, which is written for the duration of 3 hours, and the physics paper written also for the period of duration of 3 hours, and both mathematics and physics are of equal rating, so they have the same coefficient of 3. That said, we are going to get started with the video. Like I said, we are looking at the solution to FET Competitive Entrance Examination 2018 session Part 1. Now, there's a rule that you're going to follow when watching this video, so I therefore urge you to follow the rule so as to understand the video, the concepts in the video very well. Whenever I'll invite you to pick up your pen and your exercise book, and then when a question is displayed on your screen, do well to pause the video and then answer the question. Then you play the video now and follow up the lesson attentively so as to correct your errors if at all you made an error when solving. That's the rule to follow when watching this video, so as to draw the maximum that you can achieve from this video today. Let's get started immediately with question 1. Like I said, this is FET 2018 mathematics section. We're going to get started with question 1. It reads, given that x over 3 minus x times x over 3 minus x into 4 minus x is equivalent to p over 3 minus x plus q over 4 minus x. From what we have as options here, it means we need to find the value of p and the value of q that satisfies this equation, and then we identify which of the answer here is correct. Now, let's analyze the question. This question has to do with the topic in mathematics, partial fractions. Now with partial fraction, we are able to move from a single fraction, partial fracting the single fraction into its components. So there are two ways we can solve this question. We can partial fract this, and then we equate the numerator and the denominator to have the value of p and q in the numerator. Alternatively, we can simply add up these two components, p over 3 minus x plus q over 4 minus x, to have a single fraction with the same denominator as this. Then we also compare the coefficients, or we set values of x so as to have p and q. That said, let's do that. Which we are going to use the second method to solve it, but there's an alternative method that you can try when solving it. Like I said, you can pause the video and then after which you come and watch the solution. Let's get started. We have this. So we have that x over 3 minus x into 4 minus x is equivalent to p over 3 minus x plus q over 4 minus x. Now looking for the LCM here, we have that the LCM is going to be 3 minus x times what? 4 minus x, which is this denominator here, and then we are going to have this divided by 3 minus x, then times p, which is p into 4 minus x. When we divide again, when we take the denominator, the LCM, when we take the LCM divided by 4 minus x, we have 3 minus x. Then we multiply with q, we have q into 3 minus x. Now this is still equivalent to what? X over what? 3 minus x into 4 minus x. Alright, and if that be the case, you notice that if this fraction is equivalent to this fraction, we notice that the denominators are already the same. Then the numerator should also what? Be the same. So since the denominator here is equal to this denominator, then the numerator here should also be equal, since they are equivalent. What am I trying to say? Since here we have 3 minus x into 4 minus x, we have 3 minus x into 4 minus x. Now in the we are also going to equate the numerator, which is this, equal to what? X. That is what we have here. So now we are going to proceed to find the value of p and q, and like I said, we are going to be using the second method. Here we set value of x that will easily help us to find either p or q. Now setting x to be equal to 4, we now put 4 all through in this equation. Wherever we have x, we substitute 4 in the equation. We are going now to have that p into what? 4 minus 4, which is 0. It turns p into 0, which is p times 0, 0, plus q into 3 minus 4, which is negative 1. And q into negative 1 is the same as negative q, equal to what? X, and x is 4. So we have just substituted x in this equation to have q into negative 1 equal to 4, which now gives us that negative q is equal to 4, and therefore q is equal to negative 4. Now we are also going to have, we already have the value of q. We are also going now to continue the solution so as to have the value of p. Now to have the value of p, we can easily have it by setting the value of x equal to 3. And now if x is equal to 3, back to this equation again, we are going to have p into 4 minus 3, which is 4 minus 3 is 1, so I have p into 1, plus q into 3 minus 3, and 3 minus 3 will give us 0, which is q into 0, 0. So we are now going to have that p into 1 plus 0 equal to what? 3, giving me that p is equal to what? 3. Therefore, we have solved to have that p is equal to 3 and q is equal to what? Negative 4. And from here we can conclude that option C has the correct answer. P is 3 and q is what? Negative 4. We are done with the first question. Question 2. The question reads, when the polynomial p of x, where p of x is equal to ax cubed plus 5x squared plus 2x, is divided by x minus 1, the remainder is 4, the value of the constant a is... Now, let's also analyze the question and then solve. In this question, to be able to solve the question, we shall be using the factor and the remainder theorem. Now, let's make a quick reminder of what the factor theorem says and equally what the remainder theorem says. Now, the factor theorem says that if x minus 1 is a factor of p of x, then p of 1 should be equal to 0. What have we done? We have simply equated this x minus 1 to 0, because if x minus 1 is equal to 0, then x will be equal to what? 1. Then p of 1 will be what? 0. That's the factor theorem. Now, what about the remainder theorem? The remainder theorem says that if p of x leaves a remainder of r when divided by x minus 1, I'm using x minus 1 because that's the case we're having here, then p of 1 should also be equal to what? R, no more 0. The factor theorem equal to 0. Meanwhile, the remainder theorem is equal to the POF of that of the root is equal to what? 0. So if this is a factor, 1 is a root. But if this is not a factor, then p of 1 will give us what? The remainder, r. Now, let's get started with the question. We have that p of x is equal to what? Ax cubed plus 5x squared plus 2x. Now, let's equate x minus 1 to 0, and we have that x is equal to what? 1. And if x minus 1 is a factor of p of x, if p of x leave a remainder of 4 when divided by p of x, as the question clearly states, it means that p of 1 is equal to the remainder, and the remainder here is 4. It now means that p of 1 is equal to 4, and to have p of 1, we simply substitute 1 wherever we have x in the equation of p of x. So now we are going to have p of 1 equal to this. Now, simplifying this, we get a to be 4 minus 5 minus 2, and we have that a is equal to what? Negative 3. Hence, we can conclude that option C has the correct answer, where x is what? Negative 3. We proceed to the next question. Question 3 reads, the range of real values of x for which x minus 3 over x plus 2 is less than or equal to 0 is... Let's analyze the question and solve. In this question, we shall start by looking for the domain of definition of the function. At the end of the question, I will tell you the importance, the reason why I started by looking for the domain of this function. Now, to start with, it is important to know what is domain of a function. The domain of a function is the range of values of x for which the function is defined. So the range of values for which a function is defined is known as what? The domain of the function. Now we are going to let our function here to be f of x. It means we are letting f of x equal to what? X minus 3 over what? X plus 2. Now f of x from here, f of x is defined for all real numbers excluding what? Negative 2. Why? Because all this function is defined for all real numbers, but negative 2, if I look for f of negative 2, I'll have something that is undefined, because I'll have negative 2 minus 3, negative 5 over what? 0. Negative 2 plus 2 will be 0, and then any number divided by 0 is what? Undefined. So this function is not defined for values of x equal to what? Negative 2. So we can write our domain as r minus negative 2, meaning that all real numbers except what? Negative 2. Alternatively, the domain of definition of the function can be written as a range of values of x from negative infinity to negative 2, and then from negative 2 to what? To positive infinity. Now, solving the inequality, we shall proceed by looking for the critical values or the zeros. What are critical values? The critical values are values of x that makes the function to be equal to 0. And our function is what? X minus 3 over what? X plus 2. So we are going to get the critical values. Since it's a rational function, we are going to get the critical values by equating the numerator and the denominator to 0. When we equate the numerator to 0, we have that x minus 3 is equal to 0 and x equal to 3. When we equate the denominator to 0, we have that x plus 2 is equal to 0 and x equal to what? Negative 2. So the critical values we obtain, x equal to negative 2 and x equal to what? 3. Now we shall proceed to the number line, which is the final stage of our solution. On the number line, we are going to plot the two. We are going to indicate the 2 points, x negative 2 and x what? 3. So negative 2 will be somewhere here, and 3 will be to the right. On the number line, I'm placing negative 2 first because negative 2 is less than 3, so it has to come first before 3. Take notes. Now I'm going to take values of x between this range of negative 2 and 3. For instance, I'll take 0 in this range. 0 is between this negative 2 and 3, and I'll fit it in my function of f of x. I'll have 0 minus 3, negative 3 over 0 plus 2. I'll have negative 3 over 2, which is negative 1.5, which is a negative number. All I'm interested in is the sign. It's negative. So that is why my function in this region is negative. Also, I'll take any value in this interval, any number that is greater than 3, and I'm going to take, for example, 4 or 5. If I put 5 in this equation, I'm going to have 5 minus 3 is 2, and 5 plus 2 is what? 7. So I'm going to have a positive number divided by a positive number, which gives me an overall positive. So in this region, we are going to have positive, 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 because even here, if I take any number like negative or negative 3 here, I'll have negative 6 over what? Negative 1. If I take negative 5, I'll have negative 8 over what? Negative 3. So I'll have a negative divided by a negative, which the overall will give me what? Positive. Alright, so now in my question, I am the function. The question says the range of values of x, range of real values of x, for which x minus 3 over x plus 2 is less than or equal to 0. For this function to be less than or equal to 0, it means on the normal line I'm looking for the region that is less than 0, and that region will be between here, because this is the region that can be negative, and the rest, these ones are what? Positive. So my region is here. The range of values of x for which this function is less than or equal to 0 is this region between -2 and then 3. But I'm going to restrict something. Like I said, the reason why I started by looking for the domain of definition of my function. Here I'm going to have that in this region x lies between -2 and then 3, but there's a restriction, because here I have that x is strictly greater than -2, but it can be less than or equal to what? 3. Why? Because my function is not defined at -2, as we clearly saw from here that it is defined for all values of x except -2. So if I put -2 in my function, it will be invalid. Therefore the range of values of x for which this function exists does not include -2. That is why it is strictly greater than. X must be strictly greater than -2, but it can be less than or equal to what? 3. So we can now conclude that the correct option is, the option with the correct answer is option B, -2 less than x less than or equal to what? 3. So you can just imagine that if you did not start by looking for the domain of definition of the function, then you might have been tempted to take option C as the correct answer, because that's the option that it also includes -2 as part of your solution. Alright, we're going to continue to the next question. That's all about this question. We have that option B has the correct answer, and this is the correct region. We're going to proceed to question 4. Now, question 4 reads, the value of half the log to the base 2 of the square root of 8 is. Now this question has to do with what? Logarithm. So to solve this question, we're going to use the basic laws of logarithm to solve the question. Now we have that half the log to the base 2 of the square root of 8. To begin with, we know that we can express the square root of 8 as 8 raised to the power half. And then from here, we know by the fundamental laws of logarithm, one of them equally states that the log to the base b of a to the power n, this power can drop down here and we'll have n log to the base b of a. And that's exactly what is going to happen here, because this half is a power and it's going to drop down here, and it will have half times half, then now log to the base 2 of what? 8. That's what we're going to obtain. Half times half will give us 1/4 log to the base 2 of 8. And then 8 can still be written as what? 2 to the power 3. And then this 3 is also a power which is going to drop here, and we're going to have 3 times 1/4, which is 3/4, 3/4, the log to the base 2 of 2. And still, by the another fundamental law of logarithm, we know that log to the base a of a is equal to 1. Log a base a is equal to 1. This means that log 2 base 2 will also be equal to 1, and we're going to have that 3/4 log 2 base 2 is equal to 3/4 times 1, which is simply equal to what? 3/4. Therefore, we have that half log to the base 2 of the square root of 8 is equal to 3/4. And from here we can conclude that the option with the correct answer is option D, because we have here D is equal to what? 3/4. Proceed to question 5. The question reads, when 3 minus 2x raised to the power a half is expanded in ascending power of x, the range of values of x for which the expansion is valid is, and here are the options where only one answer is correct. Let's start by analyzing the question, then we solve. We need to find what? The range of values of x for which 3 minus 2x raised to the power a half is valid. That's our objective. Now, we shall first of all express 3 minus 2 to the power 3 minus 2x raised to the power half that were given in the form 1 plus ax raised to the power of n. And then when we have already expressed this in the form 1 plus ax raised to the power of n, then it is going to be valid. The range of x will be valid where the magnitude of ax, the absolute value of ax is less than 1. The absolute value of ax must be less than 1. Then we say that it is what? Valid. Then we'll have that as a range of values. Alright, so let's proceed with our solution. We are going to start by expressing it as in the form of 1 plus ax all that raised to the power of n. And then the only thing we can do to have 1 here is to factor out 3, or to divide all through by what? 3. So we'll factor out 3 instead. That's the right language to use. We factor out 3, and when we factor out 3, we are going to now have 3 into what? 1 plus negative 2/3x, then all that raised to the same power of what? Half. We have just factored out 3 from that equation. And then for this to be valid, like I already used this example to explain that when we have already expressed in the form 1 plus ax all that raised to the power n, the absolute value of ax must be less than 1. Then so our ax here is what? Negative 2/3x. The absolute value of this should be what? Less than 1. And by the basic rule of absolute value, if this is less than 1, then it means this absolute value, this boy lies between what? -1 and 1. It lies between -1 and 1. It means it is actually greater than what? -1, and then it is less than 1. Because a negative, when we have the absolute value when we have the absolute value of a number, it is that number can either be the number inside the absolute value function can either be positive or what? Negative, but the magnitude of the number, the magnitude remain the same, but the sign can actually change. So it can be bounded by negative of it and the positive of it. Alright, so now we are going to have that 2x on 3 or 2 on 3x lies between -1 and then 1. We'll just multiply all through by 3 to have -3 less than -3 less than 2x, then less than 3. Now what next are we going to do? We are now going to remember we are modeling something. We are now going to have we need x here. We need to have x standing alone because we need the range of values of x. So we need x. So that's why we started by what? Multiplying by 3, and then we got here, and then we continued by dividing by 2 to arrive here. So we have -3 on 2 less than x less than what? 3 on 2. So we have arrived at our answer. We can find the option B, giving us the right answer, -2 on 3 less than x less than what? 3 on 2. That's all for that for that question. I will proceed to the next question. Question 6. It reads: the sum of the first n terms of a sequence is given by Sn, which is equal to 3n squared plus n plus 3n squared plus n. An expression for the n term of the sequence is, alright, we are given the sum of the first n term of a sequence and we are requested to find the expression for the n term of that sequence. So let's get started. I've already analyzed the question. We have the sum of the first n term is given by what? 3n squared plus n. Now the formula says Tn, which is the n term, Tn is given by what? Sn minus Sn minus 1. Sn minus Sn minus 1. So we are going to first of all start by looking for Sn minus 1, because we are given Sn and Sn is equal to 3n squared plus n. That is our Sn. Then we need to look for Sn minus 1. So what is now Sn minus 1? Sn minus 1 is equal to, we are simply going to replace n with n minus 1 here. So we have 3 into what? N minus 1 all that squared plus n minus 1. And then this is what we get. This is what we get: 3n squared minus 5n plus 2. And then now our Tn, we are going to substitute in this equation. We are going to substitute our Sn and our Sn minus 1. So our n term will be given by Sn minus Sn minus 1. So we have Sn 3n squared plus n minus, then this is Sn minus 1, and it gives us what? 3n squared plus n minus n squared plus 5n minus 2, where we can clearly see that 3n squared minus n squared is already 0. They will actually cancel each other. And then finally we have that the n term is given by what? 6n minus 2, where we can see factor out 2, because 6n minus 2 is not one of our option here. We cannot take it. We are simply going to factorize out 2 to have 3n minus 1. It looks more beautiful. Tn, the n term is given by 2 into 3n minus 1, and from here we can now conclude that option B has the correct answer: 2 into 3n minus 1. We are done with question 6 and we'll move on to question number 7. Question 7 reads: the sum to infinity from r equal to 1 to infinity of 15 times 1/4 raised to the power r. That's what we're calculating. So question analysis and solution. This is what the question says: the sum from r equal to 1 to what? To infinity. Now the formula says that the sum to infinity is given by sum to infinity equal to what? A over 1 minus r, where a is the first term and r is what? The common ratio. Alright, so for us to have the first term and the common ratio of this sum, we need to have the first term by replacing r equal to 1. For r equal to 1, we are simply going to have 15. The first term, that's why I'm starting from r equal to 1, from my r here equal to 1, because I want to have the first term. If it was the second term, then here r will be what? 2. Sorry, this is sum. I will replace the arrow here. The arrow here is 1 in this case. For the second term, the arrow here will be what? 2. And for the third term, the arrow here will be 3, and so on. Then this sum means the sum of all of the terms, all of them, from r equal to 1, r equal to 2, r equal to 3, r equal to 4, r equal to 5, right up to infinity. So for the first term, we simply have that A will be equal to what? 15 over 4, because r here will be 1. Then we simply multiply to have what? 15 over 4. We already have the first term A, and now what we need is the common ratio. But for us to have the common ratio, we need at least 3 consecutive terms of this sequence. Once we have the any three consecutive terms, then we can obtain the common ratio. Now we already have the first term, we can obtain the second term and also the third term. Here they are. Now to get the common ratio, we verify that r2 over r1 is equivalent to r3 over r2. So we have to verify that this one r2 over r1 is equivalent to r3 over r2 for any 3 consecutive terms of the sequence. So verifying that, we're first of all going to verify r2 over r1, which gives us 1/4, and we do the same for r3 over r2, which also gives us what? 1/4. So we have verified that this one r2 over r1, which is 1/4, is equal to r3 over r2, which is also 1/4. So from here we can conclude that the common ratio is what? 1/4. That the common ratio of the sequence is, after we have already verified, we can conclude that the common ratio is 1/4. Now we can now substitute everything in our formula to have sum to infinity. Equal to what? The sum to infinity is given by what? A, which is the first term, divided by 1 minus r, where r is what? The common ratio. We have calculated it to have 1/4. So now we simply have 15 over 4 divided by 1 minus 1/4, and 1 minus 1/4 is actually equal to 3/4. Can do the simple subtraction of fraction here to have 3/4. Now since we have 15 over 4, then divided by 3/4 is actually going to be the same as 15 over 4. Then now times 4/3, we simply just somersault this. The denominator becomes the numerator when we change the division sign to what? Multiplication. And then if we do this, the 4 will cancel, and 3 here, 1, 3 here. Our answer, we're going to have 5. So it means the sum to infinity is equal to what? 5. And from here we can now conclude that the option A has the what? Has the correct answer. Question 8. Question 8 reads: the general solution of the equation sec theta plus 30 is equal to 2. This question has to do with what? Trigonometry. The general solution of the cos function of the cos. Now it's so complicated to start thinking about the general solution of a sec function now, but we know that sec theta is equal to what? 1 over cos theta. Sec theta is the same as 1 over cos theta. It means if we have sec theta plus 30 degrees, it's going to be the same as 1 over cos theta plus 30 degrees. This is what I'm saying. So we have that 1 over cos theta plus 30 degrees is equal to 2, and this 2 can be written as 2 over 1. So now we are free to now cross multiply, and we are going to have that 2 cos theta plus 30 degrees equal to 1, and from here cos theta plus 30 degrees is equal to what? 1 over 2, because we have divided both sides by 2 to have cos theta plus 30 degrees equal to what? A half. Then now we are simply going to have that theta plus 30 degrees is equal to the cos inverse of a half, and the cos inverse of a half is what? 60 degrees. 60 degrees, or pi on 3. So now take note, please take note here. We are not going to send this 30 degrees to this other side of the equation. We are going to leave it here because it is collectively called our principal value PV, theta plus 30 degrees, not just theta. So take note, never make the mistake of sending the 30 degrees maybe to the right hand side of the equation. So we are going to have that our PV is such that theta plus 30 degrees is equal to what? 60 degrees. Now our PV, we can also call it theta n. Theta n is equal to 60 degrees. Now the general solution of cos theta is what? Theta n equals to 2 pi n plus or minus PV. So our theta n is what? Theta plus 30 degrees, and our PV is what? Pi on 3 or 60 degrees. So that's what we're going to do. We're now going to have that theta plus 30 degree, which is our pi n, is equal to 2 pi n plus or minus PV, and our PV is what? 60 degree. Now we also know that pi is the same as 180 degrees, so we're going to replace 180 degree here times 2, which is what? 360 degrees. We're now going to have that theta is equal to what? Theta is equal to the 360 will come here. Theta will be equal to 360 pi n, then 300 will cross here to give us 60 minus 30. Voila. So we're simply going to have, this is 2 pi n plus or minus 60 degree. It becomes 360 n, because pi is already 180 and we have already multiplied by 2 to have 360. So now 360 n plus or minus 60 degrees, then minus this 30 degrees. So I'm going to have that theta is equal to 360 n plus or minus 30 degrees, and that is our general solution. And from there we can conclude that option C has the correct answer. We are now in question number 9, the 9th question, which has to do with trigonometry. Here our objective in this question is to resolve a trigonometric identity. We are going to use trigonometric identity to resolve this problem. Alright, let's get started. This is what the question says, and to solve this we need to make very good use of our trigonometric identities that we all know already. Alright, these are the trigonometric identities that we are going to use, because looking at the problem, I'm seeing two possible ways that we can solve. So I'm going to solve one and I'll assign you to do the other, because it's going to give us the same answer, and there's of course no need for me to solve all the two methods. I'll just describe how to do it and you'll be charged to do it. Then you can send your solution through the comment section below. I'll have time to go through it and check whether it's correct or wrong. Now we're going to use this identity for sine and this identity for cos, and we're going to apply that in what we have here. It's going to be helpful to us. So that's method 1. I'll explain it and I'll tell you how to do method 2. Now doing this we have that 2 sine 3 theta cos theta over 2 cos 3 theta cos theta is equal to what? Sine 3 theta over cos 3 theta. Already, why am I having 2 sine 3 theta cos theta with the use of this identity here? Now I'm having sine 4 theta plus sine 2 theta, which is equivalent to this sine A plus sine B, which is the same as sine of A plus B on 2. So I have sine of A plus B. A plus B is 4 plus 2. 4 theta plus 2 theta over 2 gives me what? 3 theta. That's the source of this 3 theta. Then now times what? Cos A plus B over 2. So that's basically what I have done here to have this, because the cos of cos of that, we have a plus b on 2, and a is what? 4 theta, b is what? 2 theta. And the same thing goes here in the denominator, and we are now going to have this is equal to what? Sine 3 theta over cos 3 theta. And sine theta over cos theta is the same as tan theta, meaning that sine 3 theta over cos 3 theta will be the same as what? Tan 3 theta. Because this is simply sine 3 theta over cos 3 theta, because this, we have like terms that are going to cancel in the numerator and the denominator. 2 sine 3 theta and 2 cos 3 theta are going to cancel, and I'll be left with sine 3 theta over cos 3 theta. So that is it. That's it. I'm going to have that my answer is what? Tan 3 theta. So let me describe how you can do the other method. We have that option B has the correct answer. Is it B? No. A. The answer is A. Sorry about that. The answer is A, not B. Tan 3 theta. Now, alternatively, another method could be used. You can make use of the double angle identities for sine and cosine. So I'll leave you to solve this and this second method, and drop your solution in the comment section. You're obviously going to have the same answer with me, A, tan 3 theta. So we'll proceed. This is going to be the last question in this session. The sine of the acute angle between the plane pi and the line L, where pi is such that x minus y minus z is equal to 2, and L is such that x minus 2 on 2 equal to y plus 1 on 2 equal to z on 1 is, so we need the sine of the acute angle. The sine of the acute angle between a line and a plane. So that's what we can say about the question. We are going to make some recall that will help us to solve the question. Our recall from what we learned in A level mathematics. Now, what is an acute angle? Acute angle was treated since Form 1, and we said acute angle are angles that are found in the first quadrant of the Cartesian plane, or these are angles that are greater than, these are angles that are less than 90 degrees, because if you are found in the first quadrant of the Cartesian plane, then you must be less than 90 degrees. Now, also, a line is characterized by its direction vector. Note that. Meanwhile, a plane is characterized by the normal vector, and the normal vector is a vector that is perpendicular to the plane. So with this, we are good to go. We can start solving the question now. Let's now also remember something. The sine of the acute angle between a line and a plane is given by sine theta, which is equal to n dot d over n magnitude d magnitude, where n is the normal to the plane and d is the direction vector of the line. So I hope you already know how to do dot product of two vectors, because this n, the arrow here means the n is a vector. In fact, it's a vector that is normal to the plane pi, and z is a direction vector. It's a direction vector of the line. So we have the dot product of two vectors over divided by the product of their norms, or the norms, which means their magnitude, the product of their magnitudes. All right, let's continue. N is the vector normal to the plane pi, and z is what? The direction vector of the line L. Equation of the plane is given by what? R dot n equal to what? D, where R is what? Any arbitrary point on the plane, which is what? X, Y, Z, and n now is the normal to the plane. So we are going to have that x, y, z dot n. How do we get n? The normal is equal to what? 2. Now we are going to have that n is equal to 1 minus 1 1 for the plane. This is for the plane. So our interest is to first of all have the normal of the plane and also have the direction vector of the line, so that we can just substitute them in this formula and then we are already born. Now we are going to start. We have started with the plane already. Our simply, this is the equation of the plane here. So we have already x, y, z, x, y, z, and then we now have these are the numbers that if you multiply this, if you take the dot product of these two vectors, you are going to come back to this plane, here, sorry, this is plus z here, plus z, please correct it, plus z. So you are going to have, here we have x, we simply just take only the variables first. We have x, y, and z, and then after we collect their coefficient. Here we have 1, here we have -1, like I said, here is plus, so we have 1. So that is it. So and we now compare this with the equation of a plane, r dot n equal to d, r dot n equal to d. So we have that n is the same as 1, -1, 1. So now for the line, the equation of a line is given by r equal to a plus lambda d, or a plus td, where t is a parameter, t is any parameter, and then the line that they have given to us has this equation. This is the line that they have given to us, and then the direction of this line, the direction vector, is simply the denominator. But I would like to proceed in my solution to show you how to look for the direction of the line, even though it's going to be the same, 2, 2, 1. So let's just proceed. I'll show you how to get the direction vector of a line. So we're simply going to equate all this to the parameter t, because we started using t already. So we're going to equate x over x minus 2 over 2 equal to y plus 1 over 2 equal to z over 1 equal to what? T. All of them, they are equal to the parameter, and then we now solve for x. Here, if x minus 2 over 2 is equal to t, then it means that 2t is equal to x minus 2, and x is equal to 2t plus 2. We'll do the same for y. Y plus 1 over 2 equal to t, and then we are going to have that 2t is equal to y plus 1, and then y will be equal to what? 2t minus 1. Then now t here is equal to z, meaning that what? Z is equal to what? T. Fine. So from here, now we can follow the equation of a line that we already know, a plus the t, which is the parameter times the direction vector of the line. So we can actually write our line like this. We can write the equation of our line like this. We have 2 minus 1 0, then plus t. Let me show you how I got this. Let me show you how I'm getting these values here. Just be attentive enough. This is my value of x, y, and then z. So I'm first of all taking these ones that don't have any parameter. I have 2, -1, and then 0 here. That's it. Then plus t, the parameter t. Then I'll come here now and take all the coefficient of t. Here I have 2, 2, 1. So this is it here. Then which now tells me that d will be what? 2, 2, 1, because I'm actually comparing this to the normal equation of a line that I know, and I now have that the direction vector d is the same as 2, 2, 1. So here I can now substitute all this into my formula of sine theta, and I'm going to obtain the sine of the acute angle. That was my initial objective. So the sine of the acute angle between the plane and the plane pi and the line L is given by r is given by n dot z, where n is the normal, dot z is the direction vector of the line, divided by the magnitude of n times the magnitude of what, z. How do I get the magnitude of a vector, or the norm? The norm of a vector is gotten by, I'll just square the entries. That means I'll square 1, I'll square this, and I'll square this. So I'll have 1 square plus minus 1 square plus 1 square. All this will give me 3, because I'm taking the square root of it now. I'll have root 3. Then all the same here, I'm going to have the square root of what? 2 square plus 2 square plus 1. So that's the square root of 2 plus 2 plus 4 plus 4 plus 1. That's 9. So the square root of 9. And then we know that the square root of 9 is 3. So we're just going to have 3 root 3 in the denominator. But now for the numerator, we simply multiply 1 times 1 times 2 is 2, minus 1 times 2. We multiply them in the corresponding entries, please. We just multiply 1 times what? 2. We have 2. Now we multiply negative 1 times 2. We have negative 2. And then we multiply 1 times 1, and we have 1. So when we sum up everything, we have just 1 over the denominator, which is 3 root 2. So from here now we can conclude that C is the option that has the correct answer. 1 over 3 root 3. C has the correct answer. So we have finally come to the end of this video. Thank you for watching. Make sure you like the video if it was good to you. Also share the video and do well to subscribe. This is not the end of the paper. These are just the first 10 questions, well solved and well explained. So tomorrow I shall be uploading to this same YouTube channel the solution to the remaining parts of these questions. So right now, just click on the subscribe button, subscribe, and turn on your notification, so that when I upload this video, you'll be notified to come and watch. If you have any question from the video, you can drop your question in the comment section, so that in case you need explanation, then in subsequent videos I'm going to explain. Thank you so much for watching.